On the South Texas coast, a giant stirs, Starship. Gleaming in the sun, it stands as a symbol of human ambition. On August 21, 2025, its engines thundered in a static fire test, not a launch but a rehearsal for its 10th flight. Each test is a calculated step in a cosmic game. The ground shook, the sound echoing for miles, a promise of journeys beyond Earth. This test was more than a systems check, it was a dress rehearsal for a complex maneuver in orbit. SpaceX engineers were testing the heart of a new system, in-space refueling. For decades, the question has lingered: how do you refuel a spaceship in the void? Starship Flight 10 aims to answer that. Starship is the largest, most powerful rocket ever built, designed for rapid reusability. But to unlock its full potential, it must refuel in orbit. This static fire was a crucial check of the plumbing and pressures for the next big test. For all of history, our reach in space was limited by the fuel we could carry at launch. SpaceX is building the tools to change that, creating ports in the cosmic ocean. This static fire is the first whisper of a new era, an era where humanity is no longer tethered to Earth's shores. The economics of space travel are about to change. Reusability and in-orbit refueling will make interplanetary travel routine. The journey to the stars begins with fire and steel on a Texas launch pad. The future is being forged, one test at a time. Imagine pouring tea in zero gravity. The liquid floats, refusing to flow. This is the challenge of transferring fuel in space. On Earth, gravity helps. In orbit, liquids slosh and stick to tank walls. Moving cryogenic fuels, liquid oxygen and methane, becomes a daunting puzzle. These super cold liquids are dense and powerful, but always trying to boil off. In microgravity, boiling creates bubbles that can damage pumps. Pumping a mix of liquid and gas is inefficient and risky. For decades, this problem has limited our reach. Without reliable in-orbit refueling, every mission needs a massive rocket. It's expensive, complex, and restricts what we can send. Building a permanent base on another world? Nearly impossible without a solution. We need a way to move these super-cooled liquids from depot to ship. Solving this isn't just convenient, it's essential. It's the key to unlocking the solar system. With it, Mars missions become routine, not heroic one-offs. We can build infrastructure, create a true spacefaring civilization. The challenge is mastering fluid physics in an alien environment. It demands new engineering, new thinking. SpaceX is tackling this head-on. Their work is about more than plumbing. It's about enabling humanity's next leap. The cryogenic conundrum is the final barrier to sustainable exploration. Overcoming it will change everything. The future of space travel depends on mastering this invisible challenge, and the solution is finally within reach. How do you pour liquid in zero gravity? SpaceX's answer: create your own gravity. Starship and its tanker won't just dock, they'll connect at 4 points, forming a rigid structure. Once linked, the combined ships spin gently, creating centrifugal force. This artificial gravity pushes fuel to the tank's edge, settling the liquid. Pumps can then draw pure fuel, free of bubbles. The four-port system ensures the massive ships withstand the spin. It's a cosmic centrifuge, turning chaos into order. But there's more. The tanker increases its tank pressure, the receiving ship lowers its own. This pressure difference helps push fuel across. Spin and pressure work together for efficient transfer. All of this happens autonomously, high above Earth. This system transforms Starship into the backbone of an interplanetary network. It's not just a pipe, it's a breakthrough in space logistics. With this, fleets, depots, and a highway to the stars become possible. Refueling in orbit rewrites the rules of exploration. A Starship launches, uses most of its fuel to reach orbit, then docks with a waiting tanker. After refueling, it's ready for the Moon, Mars, or beyond. The size of your rocket at launch no longer limits your mission. Launch crew and cargo, then send up tankers to fill the tanks. This is orbital aggregation. Now we can send massive habitats to Mars or build lunar outposts. The orbital petrol station breaks the tyranny of launch windows. Compare this to single-use landers. Starship is a reusable transport system. It can land, return, refuel, and repeat. This drives down costs and opens space to infrastructure and permanent bases. It's not about flags and footprints, it's about lasting presence. The orbital petrol station is the enabler of everything to come. It turns the solar system into our backyard. Space is no longer a distant frontier, it's a place we can settle. The future of exploration is built on the ability to refuel and reuse. This is the foundation for cities on other worlds. The age of true space access has begun. NASA sees the power of this technology. For Artemis, it's chosen Starship as the lunar lander. NASA isn't just a customer, it's a partner. The agency wants a full demonstration of in-orbit cryogenic transfer by 2028. 2 Starships will dock, spin, and transfer liquid oxygen in orbit. Success will prove the concept and pave the way for lunar landings. This is a critical checkpoint for American space exploration. NASA sets the goals. SpaceX brings innovation and speed. This public-private partnership accelerates progress. Meeting the 2028 deadline will signal a new era of leadership. America will have a reusable, refuelable interplanetary system. The next chapter of exploration will be led by those who master this technology. Mastery comes through failure. SpaceX knows this well. Their philosophy: build, fly, test, fail, learn, repeat. Early Starship prototypes exploded, but each failure brought valuable data. The cryogenic transfer system faces similar setbacks: leaks, failures, redesigns. The 2028 NASA deadline drives relentless innovation. Unlike traditional aerospace, SpaceX builds and tests in the real world. This hardware-rich approach uncovers problems simulations miss. It's risky, but it accelerates progress. The race to perfect orbital refueling is SpaceX's most important challenge. The success of Starship, Artemis, and Mars dreams depend on it. Each static fire is a step forward. There will be more failures, but each one strengthens the system. Through trial by fire, humanity learns to master space logistics. The journey is hard, but the rewards are immense. Every setback is a lesson on the road to the stars. Today's space race is about logistics, not just prestige. It's a race to build a sustainable presence in space. Mastering in-orbit refueling is the key to winning. The nation that moves people and materials efficiently will lead. It's about building infrastructure, not just visiting. Starship's refueling gives America a head start. While others focus on reaching orbit, SpaceX is building a shipping network for the solar system. This enables space stations, telescopes, and planetary defense. It's about controlling the high ground for the future. Humanity's survival may depend on becoming multiplanetary. Settlement is a question of logistics, moving vast supplies reliably. The static fire in Texas is a small step, but a critical one. We are learning not just to visit space, but to live there.